Hello everyone, I am Dr. Nikita Singhal. In this presentation, I am going to discuss Hofmann-Loeffler Freytag reaction. In Hofmann-Loeffler Freytag reaction, N-halogenated amines are the reactants when they are treated in acidic media followed by thermal or photochemical condition. In presence of basic workup, they provide the cyclic amines. So this is a very important reaction by which we can prepare pyrrolidine derivatives. Usually 5 and 6 membered rings can be formed, but pyrrolidine is preferred product in Hofmann-Loeffler Freytag reaction. So when N-chloroamines or N-haloamines are treated in acidic media in thermal or photochemical light followed by the basic media, it provides a pyrrolidine derivatives, that is a 5-membered nitrogen containing ring. Now coming to the mechanism part. Initial reactant is N-chloroamine. So when it is treated with acid media, then protonation will takes place. So this H plus ion from acid will attack on the nitrogen atom and it will convert into the ammonium chloride like species. Now as it is irradiated with light radiation or in thermal condition, nitrogen halogen bond will break in homolytic manner, so it will convert into Cl radical and nitrogen radical. Cation was already present on nitrogen, so we will get the cationic radical. In the next step, nitrogen cationic radical will abstract the hydrogen from the del position. So it will create a carbon radical. Next, because in this reaction chlorine radical is obtained by the homolytic cleavage, this Cl radical will attack on this carbon radical and will produce this compound. Followed by the basic media, this H plus ion will be released from this nitrogen and we will get the lone pair back on the nitrogen. So this lone pair will attack on the del carbon and will give the ring cyclization product. Till now this nitrogen contains the R and H group. Because it has a 4 valency, so it contains a positive charge. But we have a basic media, so the base will abstract this proton and will form the pyrrolidine derivative. So it will be our product. Again I am going to repeat the mechanism. N-chloroamines will be treated with the acid and it will protonate the nitrogen. So we will get the alkyl ammonium chloride salt. In presence of light or thermal condition, homolytic cleavage will take place, which will produce the cationic radical. This cationic radical will abstract the proton by intramolecular hydrogen abstraction process and we will get a carbon radical. This carbon radical will abstract the chlorine radical and convert into tertiary amines product. In presence of basic media, hydrogen will be abstracted from the nitrogen and it will convert into amines. These amines will attack due to the nitrogen's lone pair on the del carbon and releases the chlorine from this and gives the nitrogen containing 5-membered ring. In presence of basic media, H plus ion will release and forms the pyrrolidine derivative. Now we will discuss some examples. How this reaction can be applied in organic synthesis. First example, we have taken the 1-bromo-2-propyl piperidine. This molecule, first we have to identify, is this a Hofmann-Loeffler Freytag reaction? So nitrogen contains a halogen and our reaction condition is giving the H plus media with a hot condition followed by the basic workup. So it is a Hofmann-Loeffler Freytag reaction where the H plus will attack on the nitrogen and it will contain a positive charge. Then this bromine will eliminate from here. It will generate a cationic radical. After the cationic radical formation, the bromine will bromine will eliminate and goes to the carbon radical, that is the hydrogen abstraction takes place from the fifth carbon, that is a del carbon. So it will form the conocene product, that is a natural product. Except that if we are taking the N-chloro N-methyl pyridine 3-ene butane 1 amine, this is this compound, then in presence of acidic media and followed by the basic workup, will get the nicotine as a product due to the Hofmann-Loeffler Freytag reaction. Further, this reaction is very useful to give the bicyclic compounds, like if N-methyl cyclohexane amine will treated with the NCS, that is N-chlorosuccinimide, then this will provide the chlorine to the nitrogen atom. So now it is N-halogenated amines. In given condition, it will abstract the del proton and forms the bicyclic product by the same mechanism of the Hofmann-Loeffler Freytag reaction. Now, when we are treating this compound in acidic medium, so this will contain nitrogen will protonated first, then in thermal condition nitrogen chlorine bond will break and cationic radical will generate. That cationic radical will abstract this del position hydrogen, generating the carbon radical. This will again abstract the chlorine from the reaction condition. Followed by the basic workup, it will give the proline molecule. This ester molecule is hydrolyzed in acid due to the acidic hydrolysis. Now, N-chloro N-methyl octylamine will treated with the following condition will give the bicyclic product due to the Hofmann-Loeffler condition. So this reaction is useful to synthesize the nitrogen containing heterocyclic compounds, which are very useful in natural product synthesis. Many steroids, many alkaloids are synthesized by this reaction. Now coming to the one more example where we have taken this complex molecule where the nitrogen contains the chlorine. So this is an N-halogenated amine in presence of trifluoro acetic acid and photochemical radiation. We know that this can convert into 5-membered ring. In presence of basic media, we'll get the 5-membered ring here. So what will happen? There's one more point that del hydrogen should be abstracted, which is more approachable sterically. So here two del hydrogens are present with respect to nitrogen. This is 2, 3. This 4, or we can take this 4. Okay, so that which hydrogen should be abstracted. This is more sterically approachable in compared to this hydrogen. So our product will be this compound. Thank you.